Thank you for organizers and everyone. We are happy to have such a kind of occasion to present our recent activity on AWS Quantum. ここから日本語でお話しさせていただきます。AWS
I was speaking in Japanese. I'd like to share quantum computing on AWS and Amazon Braket, which is a quantum computing full managed services available from AWS. And I am working at AWS I'm sure the architect for quantum computing as well as supporting customers for technology perspective. I was working at the National Institute for Information using optical semiconductor. Quantum simulation is the area that I was responsible for, and a basic study for that. Toward my end of the career at that institute, we were using NIA and had a collaboration with the Stanford and NTT with this joint research. We connected it with the AWS and made it available to public. But Amazon Braket, which I'll share more with you, the concept actually cuts across similar common themes with my research there. And now Amazon Web Services, there were a few keynote speakers who mentioned about the AWS. Amazon Web Services is providing cloud computing. More than 200 services are available, supporting different workloads. CPU, GPU, computing resources are provided. We have storage as a service, and the developers also has some tools access, which is database. Machine learning is my background. There are a lot of easy-to-use technology available, services available in machine learning. On quantum computing, we wanted to make sure quantum hardware, we will make it available to customers as easy as possible. That's what we do at Amazon Web Services. As a matter of fact, there are hundreds of millions of hundreds and thousands of people are using them. Companies are using them. Japan and globally, not only private businesses, there are many different players who are using our services. I'd like to now spend some time talking about quantum computing initiative at AWS. AWS has something called Quantum Center for Quantum Computing. We just made an announcement about that. It's a research center based in California. It is right next to Caltech. And this is a quantum research center for AWS. Quantum computing's global leading research and the AWS engineers will be collaborating together at that location. But as a researcher, so superconductive quantitative qubit is so AWS Quantum Research Center. This team is being led by him, and Phil and Branda, as well as John Preskill, the leading professors who are leading our research. These research teams are making some publications. What makes them unique is using fault-tolerant quantum is being done with superconducting qubits, not only with hardware. It talks about like a different architecture. How can we minimize the use of qubits to make it effective? To cover some of the and John Preskill, this logical team. I think some of the speakers mentioned about NISQ. Noise interface quantum was actually being proposed by it. You see the copy of the paper. He's the author of that paper. So yes, hardware and algorithm, both sides are being researched, and that makes our AWS Center for Quantum Computing Research unique. I'd like to talk about Amazon Braket. Amazon Braket is if you have an AWS account, anybody will be able to have access to Amazon Braket. It's a full managed services for quantum computing. AWS we call it a managed service. What we mean by managed in this context is, so developers, let's say, they wanted to use quantum computer. Let's say quantum computing programming environment has to be provided. SDKs, like what about development environment? These becomes challenges, but we will provide everything fully included as a service. As a matter of fact, Amazon Braket have 5 different, we call it Q2B, that you can have access to 5 different types of hardware. So farthest to the left to you is like a D-Wave, Eon Kong, Wizjet, Oxford Quantum Computing. All the way to the right is Xanadu's wireless. This is the optimum quantum computing device. So all of them have very different physical characteristics. The computing mechanisms are different. So, but you can see AWS, if you have an account with AWS, anybody will be able to have a different type of hardware. If you have an account, as a matter of fact, you can use it today. And, you can actually get and open an account. If you have a credit card, there's no initial down payment required. You just get charged as much as used. So you can small start. That makes it unique. So if you want to try it, it will be a great way to try it. AWS, like I said, more than 200 developer tools are available. You can collaborate with different services and tools. And in Amazon Braket SDK is available, which is like a Python-based language. So if you're a developer, you'll be able to access those hardware and do the development. I'd like to talk about some other detailed characteristics of QPU. Rigetti IR2 and Oxfam Quantum. There are 3 different types of universal gate-based. Rigetti Ion is like a superconductive, and Ion Q is ion trap qubits. And Rigetti hardware has been available from the very beginning. We have something called AMSEN SPAN HT qubit will become available no matter who you are. And Icon is using ion trap qubits. Superconductivity requires like a 2-dimensional. So this limits the connectivities. But Ion Q, with the Ion Q trap, all the 11 qubits are fully coupled. And OQC, this is at the beginning. So this is like a 3-dimensional connections. And Xanadu, this is something that I'd like to share you with a little more detail later. This is the optical QC. And we also have D-Wave. We have D-Wave 2000Q plus advantage version is available with 5,760 qubits. This is Amazon Brackets recently made this available. This is using optical QC. Xanadu is a startup company in Canada. Just the other day, they have published on Nature, science magazine Nature, about quantum advantage optical QC with the squeeze optical pulses. And Xanadu, this company, has developed something called wireless. This is a computing. This is different from gateway style. This is optimum QC calculation has been done. So you see the laser pulse are used on computation. And there's a small writing saying OPO, where the optical pulse are being fired, and each one of them are calculated elements, and it says that 260 modes. 260 modes are being connected with the coupling the optical inputs, and makes 3D optical couplers. And the connections can be programmed with different types of coupling. So the output, the optical outputs, and if you run the simulation, on average, it was supposed to take 9,000 years. It's called ozone sampling. That is the calculation method. Ozone sampling is if you do this with this machine, and optical, so the machines can be very makes a high speed. So instead of 9,000 years, it can do the 36 microspec. And this was Amazon Braket next day after the release of information, it becomes available from Amazon Braket, where anybody will have access to use. Amazon Braket, there's another device that is going to be announced later today. This is something called QR computing. It's using, this is again different from gateway style. This is called analog video compilation, and neutron interactions are being used for running that simulation. So compared with high-performance computing, quantum computing, this one is much faster, supposedly. So this would be one of the examples of how this can perform much faster than high-performance computing. Now, I went through, you can actually, from the browser, you can go to Amazon AWS, and you'll be able to access to those services. These are the set of the types available from Amazon Braket. On the left-hand side, we have QPU, actual hardware on the left-hand side. The right-hand side, you also be able to choose simulators. So if you want, you can do so. And you can actually do that within the classical computing too. And so using AWS's high-performance computing, simulators comes with 3 different sets of state vector, and also computing has noises. Noise can be simulated. This is called DM1. And the other one is with the large-scale simulation is also possible with the other simulator. D-Wave is available 24 hours a day. Other devices are actually up and running every day. There are some downtimes, but if you send a job, QPU, whenever QPU becomes ready, it will start getting implemented right away. So this is how the architecture looks like. Developers will access from browser coming to the managed notebook. That's like an environment for development. Or you can directly come using your your computer, and you can just ask for the job. Amazon Braket, this is so you come to AWS Cloud first, and then from there you call QPU. And this is through API. You call it up, and the results of and the logs are all being stored in Amazon AWS. Some people ask, is cloud computing safe? But all the connection networks are being encrypted. It's quite a completely secure framework. And sorry about that. And the development environment. Within the development environment, you will be able to treat and being able to process information data securely, and I earlier talked about, when talking about the Amazon Braket, the hybrid jobs is also available. If you want to implement NISC, and the quantitative classic computing can be done, but hybrid to be very efficient way for having that. And if you want to implement B2E or QOE, you might be in Japan and you want to send the job to North America. That's like iterative computing has to be done between Japan and North America. Iteration can be the slow part, right? Even if the quantum computing is very fast. But with the hybrid process, this is very efficient in terms of physical implementation of what you've been doing. And this Amazon Braket is using Python. SDK is available. So with a matter of a few clicks, you'll be able to launch that development environment. So developer will come to the environment with a matter of a few weeks. Jupyter level-based development environment will be starting up right away. Amazon Braket Python SDK will enable you to start the programming right away. And this is how the prices look like, different from device to device, but by task, by shot, pricings are being put together. There might be a computing table, so I'll give you an example. For simulator, the calculation resources needs to be made, so it's price per hour, but not by hour, by minute, but 15 seconds. Is the smallest unit. So $5, for example, if you use it for 1 hour. D-Wave, one task with the 2,000 sample shots is 0.3. And for ETH 2, 10,000, one task with 10,000 multi-shots comes with that unit price. Therefore, like a pricing is set that enable you to do a very small start if you're going to be affordable. AWS is supporting many different customers. Our challenge is to how to develop software talents in private businesses. We get that asked that question. What we are providing for those challenges is now quantum computing. What we want to see is all developers, we want to provide the environment which all the developers, as many developers as possible, will be able to have access to that. So Amazon Braket is developing our work to make sure that it becomes available to as many people as possible. And library and SDK needs to be developer friendly. NISC is not very complicated, you might ask, but we want to make it as easy as possible. So setting the environment to make it easy is very important challenge for us. And also quantum expertise developers. Those are the talents that might be available in companies. So AWS can be a partner, and quantum computing partners. Having those partners are important. AWS also has those partners, and we also are serious about giving training. AWS is working with the University of Osaka to put that training program just recently. Now, developer-friendly environment, one example about that is Qiskit. Many of the people here might be using Qiskit. Why not use Qiskit in Braket? Actually, a lot of requests like that. And Qiskit, Braket provider, is finally become available on our platform. So Qiskit algorithm, Qiskit Q2B, you can, or for Q, or Aspen M1, these are the QPU available in Amazon platform, and you'll be able to use them backend. The other thing is Penny Lane is being supported from the very beginning of its release. Quantum Circuit is, if you know how to use Tensor, you probably know how to use it. So it's very easy to write that code, and that is another thing that's available for the Amazon Braket. And it's a simulator. We just recently had this announcement. So if you want to do the hybrid calculation, as a matter of fact, so QPU and Amazon environment get connected and you run the hybrid. And if you want to simulate it, this is one of the ways to NVIDIA's Q Quantum. Penny Lane can be called up. So hybrid quantum computing itself becomes very much faster, and we just made the announcement about that recently. So lastly but not least is the how we are supporting our customer for quantum computing. Like I said, quantum computing, so helping user companies. So developing talents capability is also very important, and we are trying to, if you're exploring how to practically working with having partnership with their quantum experts. AWS has something called Quantum Solution Labs. This is like you have to pay for that too, so we will help customers can use the quantum solutions in their practical. We have quantum experts actually helping directly to customers to solve customer solutions. And we also have collaboration with their various partner companies. As a matter of fact, you have a list of partners here. These are the companies we are helping our customers solve quantum level solutions together. And these are the examples of IOI, Nisei, Dowa, USA is just one example. So this is a telematics data from autonomous driving while being driver score will be used, and there's a proof of concept project with that. So solution architect from AWS, like somebody like me, will actually helping them with Fidelity Center for Applied Technology. And this is a financial industry's cloud-based POC was being implemented with this specific example. And the other one is an example from Osaka University. They have a booth back there. And So Quantum Software Research Hub is there's that location, and they were helping training people. AWS is also helping them. This is the academia, industry, and government collaborations to help customers, help private businesses improve on that one. Nikkei and Utsunomiya University was personalizing newsletter using, and they have like validated the effectiveness of newsletters. And I talked a lot today, but many customers are now using software development using our solution, and the Amazon Braket was a platform to enable to do that. Thank you very much for your attention.